Hello. Today we're going to look at equations and inequalities which contain absolute values. Let's take a look at our objectives for the day. First, we want to be able to solve absolute value equations by using the distance definition. We want to solve absolute value equations algebraically. We want to solve absolute value inequalities by using the distance definition. We want to solve absolute value inequalities algebraically. And we want to solve absolute value inequalities that require a transformation. We want to solve special cases of absolute value equations and inequalities. And we want to solve absolute value inequalities to describe distances. Now recall the definition of absolute value. Absolute value gives the distance from A to 0 on a number line. Now we can use this definition to help us solve the equation the absolute value of x equals 5. Now we know that x is 5 units from 0 on a number line. So if we look at our number line, we find that we have two values that are 5 units from 0. So our two solutions are -5 and 5. And here's our solution set, which contains the two solutions to our equations. Now, let's look at the distance between any 2 points A and B on the number line. These distances are given by either of these two absolute values, the absolute value of A minus B or the absolute value of B minus A. We can use this idea to solve an equation that looks like this. The absolute value of x minus 2 is equal to 4. Now what this is telling us is that the distance between x and 2 is equal to 4. Let's look at this on a number line. Here we have a number line. We're primarily interested in the number 2 and those numbers that are 4 units from 2. Those two numbers are -2 and 6. These two values, -2 and 6, give us the solution set to our absolute value equation. Now, we need to look at some rules for simplifying absolute value equations. First, for b greater than 0, the absolute value of a equals b if and only if a is equal to b or a equals the opposite of b. Our second rule tells us that if we have the absolute value of a equals the absolute value of b, then this is true if and only if a equals b or a equals the opposite of b. Now let's look at an example here that involves the first type of absolute value equation. We want to solve the absolute value of 5 minus 3x equals 3. Now we know that 5 minus 3x must be 3 units from 0. So 5 minus 3x equals 3, or 5 minus 3x equals -3. Now solving the first equation, we have -3x equals -2, or x equals 2/3. And solving the second equation, we have -3x equals -8, or x equals 8/3. So our solution set consists of these two values, 2/3 and 8/3. Now let's look at an equation of the second type. We want to solve the absolute value of 2k minus 3 equals the absolute value of 5k plus 4. 2k minus 3 equals 5k plus 4, or 2k minus 3 equals the opposite of 5k plus 4. Solving the first equation, we find that 2k equals 5k plus 7, -3k equals 7, or k is equal to -7/3. Solving the second equation, remember we must distribute the negative sign. We have 2k minus 3 equals -5k minus 4. 7k equals negative 1, and finally k equals negative 1/7. So our solution set consists of the two numbers negative 7/3 and negative 1/7. Now here's a problem for you to solve on your own. We'll pause the tape and give you a chance to do that. Let's look at our solution to this problem. We have x plus 2 equals 3x plus 8, or x plus 2 equals the opposite of 3x plus 8. Solving the first equation, we have x equals 3x plus 6, or negative 2x equals 6, or x equals negative 3. Solving the second equation, we have x plus 2 equals negative 3x minus 8, 4x equals negative 10, or x equals negative 10/4, which reduces to negative 5/2. So our two solutions here are negative 3 and negative 5/2. Now, our definition of absolute value can be extended to solve absolute value inequalities also. If we look at the absolute value inequality, the absolute value of x is less than 3, then we're looking for all real numbers whose distance from 0 is less than 3. If we look at our number line, we recognize that all the numbers between negative 3 and 3, excluding the endpoints, have a distance which is less than 3. So we see that all the numbers in the interval from negative 3 to 3 would satisfy this inequality. Now we could also have an absolute value inequality with a greater than sign. Here we have the absolute value of x is greater than 3. Now we're looking for all those values of x which are more than 3 units from 0. Looking at our number line, these would be all the numbers to the left of negative 3 and all the numbers to the right of 3. Now, keeping these ideas in mind, we have two more properties of absolute value that we can look at to solve inequalities. For any positive number b, our first property states the absolute value of a is less than b if and only if a is greater than negative b and less than b. Our second property states that the absolute value of a is greater than b if and only if a is less than negative b or a is greater than b. Now let's apply these properties to an inequality. We want to solve the absolute value of x plus 1 is less than or equal to 3. Now this is telling us that x plus 1 must be between negative 3 and positive 3. And that's from our first property. Now we can finally solve this problem by subtracting 1 from each of the 3 parts, giving us that x is greater than or equal to negative 4 and less than or equal to 2. In interval notation, remember, our solution set is the interval from negative 4 to 2, and this is a closed interval. Please note that what we're saying here is that x is within 3 units of negative 1. Let's look at this on the number line. X, which can be any number between negative 4 and 2, is within 3 units of negative 1. Remember that x plus 1 is equal to x minus a negative 1. Let's look at this example.